introduction here. Our next speaker, William Woodruff, on securing your package ecosystem with trusted publishing. Take it away.
Thank you. I know we all heard a little bit yesterday about OIDC, so I feel like a lot of the details were filled in there. Hopefully this will round out some more knowledge for everybody in this audience, especially those among you who manage or maintain packaging indices. Without further ado, actually, one more ado. I tend to speak somewhat rapidly when I'm on stage, so if you find that I'm speaking too quickly, just raise your hand and I will try to slow it down, so thank you. Okay, just to quickly introduce myself for those of you who haven't met. My name is William. I am the Director of Open Source at Trail of Bits. I run a small team that basically is in charge of contributing to various open source ecosystems and projects, primarily in the domains of applied cryptography and what we now call supply chain security, but pretty much anything that we have subject matter expertise in is something we try to contribute to. Trail of Bits itself, we're a relatively small cybersecurity consultancy. We do a lot of research and pen testing / type stuff as well, but happy to talk about that more after the talk. Before I go into some details about trusted publishing itself, I wanted to give some thank yous. This work was paid for by one of our clients, Google, specifically the Ghost team at Google. Their vision for PyPI security made all this work possible. They also helped facilitate and review this work along with the admins of PyPI. So that's Donald, E, Mike, and Dustin, who took my voluminous PRs and turned them into something that's workable for the millions of people who depend on PyPI. The other members of PyPI itself, the larger organization around PyPI, were early testers of this work and ensured that it was a smooth rollout for the rest of the community. I want to especially thank Svatoslav, who is the maintainer of the GitHub action for PyPI publishing. And he basically made sure that on day one we were ready to roll this out to the 750,000 people who use, or 500,000 users on PyPI who publish. And then also I wanted to specifically thank the PyPI CA maintainers for being my guinea pigs for this feature. So thank you. Cool. This talk is roughly divided into two acts. The first one is about PyPI and trusted publishing, basically how we ended up implementing trusted publishing for PyPI, what trusted publishing even is. To do that, I'll motivate it with some background, some quick history on PyPI's previous forms of authentication, and then talk about some of the outcomes we've seen so far. The second act is for everybody in this audience who maintains a package index or contributes to one. This will basically help you understand how we implemented trusted publishing and how it might benefit your package ecosystem. We're replete with some implementation tips and tricks, as well as some knock-on effects and benefits that we think will come for your ecosystem, as they will for PyPI based on this work. Okay, so I think a lot of people in this audience are probably somewhat familiar with PyPI already, but for those of you who aren't, it's pronounced PyPI. It is the primary package index for the Python ecosystem. What this translates to in terms of sheer statistics is about 500,000 projects, 5 million releases of those projects, 9 million files within those releases, since each release can have a source or a binary or multiple binary distributions, and then 750,000 users, meaning people actually publishing to PyPI, not just downloading from it. On the consumption side of that, you have roughly 20 billion downloads per month as of a few months ago. And I think as of this month, it's 26 billion. So this number is not slowly increasing. It's very rapidly increasing in terms of people depending on PyPI for their packages. PyPI has a large and storied history, but for the parts that concern this talk, it was rewritten in 2017, and ever since then, we've basically, we as in Trail of Bits and then we as in the Python community have added various security features to it. So in 2018 and 2019, I worked with others at Trail of Bits on adding API tokens and then MFA support to PyPI, as well as some security event logging. Following that, PyPI added support for malware scanning, as well as vulnerability feeds and GitHub secret scanning integration. And then this year, we enabled, after about a year of development, the trusted publishing feature, which of course is our topic. So to understand, before I get into trusted publishing itself, to understand why sort of any of this is interesting, it's good to understand what publishing a PyPI actually looks like. And so before 2019, publishing a PyPI pretty much looked like every other package index. You have a username and a password, and that is your credential, and that entitles you to everything that your account has access to. So what this means is, if you put your username and password in CI, an attacker who manages to compromise your CI and steal your password can go pivot to any other project of yours, as well as create new projects, as well as change your email or anything else that PyPI's normal user interface would allow. This, of course, has dire repercussions in terms of like revocation and monitoring, right? There's no real easy way to revoke your own password if you're compromised without going through a lengthy human process with someone on the PyPI side who confirms that it's actually you and gives you access back to your account. And then, because we didn't have security events yet, there was no way to actually really detect that someone had stolen your password until they finally actually decided to use it, perhaps months or years after stealing it. So this isn't great from a security perspective. But then this changed quite a bit starting in 2019. So while username and passwords currently still work, starting in 2019, PyPI added support for macaroon-based API tokens. So the fact that they're macaroon-based doesn't really matter for end users, but that has interesting properties I'm happy to talk about later. But basically what this boils down to is that PyPI now has these API tokens which have configurable scopes. So one of the nice things about this is that you can scope down the credential that is on your CI to just the project or projects that it needs to publish for. And then you can also have like a per user scope, which doesn't mean administrate my user, but just give me access to all of my projects. And this works really nicely. It's prefixed in a way that integrates really nicely with GitHub secret scanning. It's backwards compatible with the existing auth flows, so you don't really have to change anything in Twine or any other ecosystem that publishes to PyPI. But then at the same time, it requires users to manually configure API tokens. And so I guess the question is from here, like, API tokens were a major improvement back in 2019. Can we do even better in 2023? And to do better, I'd like to elaborate on some of the things that I think a better API token would look like. So I tend to think of security and usability as the same thing, but for the purposes of this talk, I separate them out. So for the purposes of security, one of the big issues you see with like manually configured API tokens is the number of error states that a user can induce. So a user who is overworked by their boss or doesn't have time to think about it or just wants to get it working is going to scope their tokens to the largest possible scope that works for them in every circumstance. And what that frequently means is they're just going to make it a user scope and not worry about it until months or years later an attacker who compromised that credential makes them think about it. A better API token is something that doesn't need to be manually configured or copy-pasted into a CI/CD system because those are the stress points that induce fatigue that make a user do those things. Similarly, like I said about revocation earlier, even though API tokens are better than passwords, revocation is still pretty manual and brittle with them. You still need to go into the PyPI user or project management interface and delete the tokens that you want to revoke. In an ideal world, tokens that are compromised wouldn't need revocation. And this is, of course, conceptually difficult to do because without revocation, you need rotation. And rotating API tokens aren't very useful. So a better API token is something that is somehow automatically expiring without requiring constant rotation, which again is a fatigue-inducing constraint. And then finally, more abstractly, API tokens still fail open in the sense that an attacker with a stolen token can wait indefinitely to use it. They are not time-bound or otherwise constrained in their ability to mess with you, which means, of course, that they are going to wait until the morning of Christmas or some other inopportune time to wreck you. User scope tokens, because they're bound to all projects at once, they necessarily grow in scope over time as you add projects to your account identity on PyPI. This in turn has scary properties like one day you become a maintainer of a critical project and your user scope token, which was only ever secured for the purpose of your pet projects, now has access to some critical project that secures the entire Python ecosystem. So these kind of like fail open schemes, we want to reduce those kind of schemes, and we want to reduce passive attack vectors where a attacker can wait for as long as they would like. We want to put the pressure on the attacker to basically act as fast as possible. Okay, so that's the security side. And like I said, I don't really think there's a security usability distinction, but I separate them out for the purpose of stuff like this. For usability purposes, API tokens on PyPI are currently associated with users, even when they're scoped to projects. And as we just heard recently, this causes significant logistical pains when a project changes ownership, or when someone is hired or fired at a different company, or when someone just doesn't need access anymore and you want to scope them down, but all of a sudden their credentials are deeply baked into the systems you've built up over years that nobody really knows how to maintain anymore. It's just not great in terms of permissions. You have this weird, messy, like trusted middle, which is someone who's managing the credential between the two services. And then there's this more abstract usability issue, which is the chicken and egg problem with API tokens. So because of how we design them, API tokens in PyPI are immutable, which I think is a good property. And because they're tied to users and projects, they can't be scoped for a non-existent project. So as a result, to securely scope a token down to a specific project, that project has to exist. But in order to securely create that project, you need to scope the token down to it. So you have this weird situation where in order to first create a project, you either have to use your username and password, fall back to what we don't want to encourage, or use a user-wide scoped token, which you then delete from your CI/CD, reconfigure a new token, put that in, and that is fatigue-inducing. So users don't want that. We want to make things easier, not harder for users. Okay, so those are the properties we want. Now I actually want to talk about the actual topic of this talk, which is trusted publishing. So the central conceit here is that we can do better than API tokens, and we can do better with OIDC Connect, or OpenID Connect, which is the technology behind trusted publishing. The key thing to realize here, and I realize I'm covering a little bit of what was talked about yesterday, is that CI/CD providers like GitHub and GitLab provide machine identities for their workflows through this protocol. These machine identities are effectively credentials, and they are strongly bound to the repository and workflow and other identity material that made them. Because these are credentials and because they are signed with public keys, they can be verified by any other third-party service that has the ability to retrieve the public key corresponding to that credential. By design, these credentials are short-lived and are scoped to an intended audience. So when you create this identity within your workflow, you say, I want this credential to only be valid for some subject. And if that subject is not the one that the service expects, the receiving service expects, it'll reject that token. So this prevents domain contamination between your services. And then finally, these OpenID Connect credentials are widely applied to other services that exist in the world. So GitHub and AWS can currently federate through OIDC. GCP can federate through OIDC. So the reasonable question in my mind is, why not PyPI as well? And surprise, that's exactly what we did. Trusted publishing is PyPI publishing through OpenID Connect. So just to give you the rough idea here, ahead of time, before the user actually intends to publish a project, they will configure what we call a trust relationship between a specific OIDC provider, such as GitHub, and the PyPI project they want to publish for. So the cool thing about this is that this trust relationship isn't actually secret. This is all public information, even if it's I mean, obviously, the repository name could be private, but hopefully your repository name doesn't contain like an API secret or anything. Nothing in there is actually like secret data that you would experience some kind of security disclosure from by accidentally leaking. And what this trust relationship contains depends on the provider you use, but for GitHub specifically, it's the username and repository slug, the workflow name that you intend to publish from, such as release.yaml, and then optionally, if you want to constrain to a specific environment, you can specify the environment name. We call that the trusted publisher. And then after this, whenever you actually intend to publish, what you'll do is the OIDC provider will create an OIDC credential, PyPI will accept that credential, verify it, scope down a temporary API token to that credential scopes, and hand that back to the CI/CD for actual publishing purposes. And again, because this all just results in a temporary API token, from Twine's perspective, or your PyPI uploading client's perspective, nothing has changed. All you've done is given it an API token that everybody knows how to handle. So this is fully backwards compatible with existing tooling, which I think is really, really neat. Yeah, and so this is what I basically just said in plain language, but as a flow diagram. So what we do is we say, oh, I trust, as a user, you go to PyPI and you say, I trust this workflow on GitHub for this project. PyPI does its magic. You ship it a credential. It verifies it. It scopes on an API token. That API token matches some project. And then you do Twine upload. So I'm going to rush a little bit because I have a lot to get through. So then this critically doesn't solve the chicken and egg problem. So I also wanted to highlight that. So what do you do about non-existent projects? So to handle the non-existent project problem, we have this concept of a pending publisher. So with a pending publisher, instead of binding to a pre-existing project, this is a temporarily associated with your user publisher that has a non-existent project name tied to it. And then on first use, that pending publisher is reified into a full empty PyPI project and a scoped API credential for that project. The benefit here is that you can only create a pending publisher if a project doesn't exist yet, and we limit how many a given user can create so they can't spam PyPI with empty projects. And then, again, the bird's eye view for this, it looks very similar to the existing flow. The only difference at all is that after receiving the OIDC credential, if the claimant in it doesn't match any existing project, PyPI will first create that project in an empty state, then create a full trusted publisher from that pending publisher, and create the scope token from there. OK, so yeah, this all works. I'm slightly surprised and pleased to say. Basically, with this scheme, we achieve all the security goals that I mentioned above. all credentials involved are temporary and self-expiring. Both the OIDC credential itself and then also the API token that we create has a fixed expiry within it. And so a user, or rather an attacker, who manages to steal that credential cannot use it indefinitely after they've stolen it. They have to use it within a fixed period, which reduces their scope. The credentials are automatically minimally scoped down to the set of projects that trust that trusted publisher, meaning that a user cannot make massive scopes or accidentally overscope their credentials or misscope their credentials for the wrong thing, so avoiding a user error mode. The user only performs configuration once, which is that initial trusted setup phase, with only public information, so there's no secret disclosure. And then finally, we break the chicken and egg problem by using pending publishers to automatically create scoped API tokens. And then, I didn't mention these before, but there are also supply chain problems that are solved by using this scheme. One of them is we sort of flatten state. The source repository itself becomes the ground truth for how to authenticate to PyPI. There's no more trusted party in the middle that shares a scoped API token with GitHub. Instead, GitHub is effectively the credential or the identity, which is then entitled to a short-lived API token. And then, like I said, this drastically smooths maintenance bumps, where someone wants to transition a project to a new owner, or someone leaves a company and should no longer be depended on for their user-scoped or user-owned credential. Okay, so that's the high level of the scheme. So I want to talk a little about the outcomes for PyPI. So as of basically, this became generally available about 6 months ago. How are we doing 6 months later? So I ran these stats last night. As of last night, about 4,300 total projects on PyPI have been configured to use trusted publishing. Of that number, about 70% have published at least one release using a trusted publisher. So there are two takeaways here. One is that adoption is pretty slow relative to the total size of PyPI. However, those who do adopt are adopting it proactively. They're seeing that documentation exists for this new feature and configuring it knowing that sometime in the future they intend to use it, which I think is pretty nice. And then just to focus a little bit on critical projects, which are projects that are either direct dependencies of PyPI or I believe are in the top 100 downloads for the last month. Of those, about 5% have configured a trusted publisher. And then again, roughly 73% have actually used that. So again, we're seeing some proactive motion. And then all that has been roughly linear over time. So yeah, just to zoom in really quickly on critical projects, you might think, oh, 5.2% doesn't really sound that good. But actually, if you break it down by downloads, 25% of the top 25 projects are using trusted publishers. And so like most ecosystems, downloads in PyPI are extremely skewed towards the top projects. So projects like URLlib3, Trusted Normalizer, et cetera, are already using trusted publishers. And so any package that depends on those, either directly or transitively, is being protected by this new scheme. Obviously, it's not perfect protection because you don't have total closure over all of your dependencies. But I think this is worth calling out because these numbers can be misleading. And then notably, even the top packages have like a power law. Like Bodo 3 is like 10 times more popular than the next thing. Maybe not 10 times. But basically, like it drops off very quickly. So even like the 10th most popular package is drastically less downloaded than the 5th most, for example. So the takeaway here for those of you in the audience, some of you probably maintain PyPI packages, and some of you probably maintain critical ones. You can have a disproportionate impact on the overall security of the PyPI ecosystem by switching to trusted publishing. Or if you're not on GitHub, for the time being, switching to API tokens at least. Please do that, because two-factor will soon mean that you can't use your password for uploads anyways. Okay, that's the summary. Now I want to talk about how some of the people in this audience could actually use trusted publishing. So this comes in the form of like a number of tips. So the first tip is about the data model. So you might think reasonably, oh, well, I have a project on PyPI and I have a project on GitHub, one trusted publisher per package on GitHub, per repository on PyPI. The reality is this doesn't actually work. Lots of companies and organizations run monorepos where the single GitHub identity maps to multiple PyPI projects, and so you want to handle that case. Conversely, there are multiple logical publishers for a single project. Now, ideally, users wouldn't do this, but in practice, what they do is if they have a Python build that has multiple architecture-specific wheels, they will fan out those builds, and then rather than fanning them back in for publishing, they just publish each wheel independently in its own architecture-specific step. And so as a result, we don't want to break user workflows for this initial rollout, so we allow that many mapping as well. So conclusion, trusted publishing is actually surprisingly many. This may, depending on your backend, if you're a package index maintainer, have surprising complexity implications for your implementation. Happy to talk about those. Okay, that's just a screenshot of what it looks like. Tip 2, OIDC is very narrowly standardized. So again, you might think, oh, this is amazing. These credentials are like global, they're standardized, they're just drops under the hood. How different could they be? The reality is that individual providers both have latitude in terms of the number of claims they provide and the format of those claims. You can only assume very, very basic things about the claims themselves, things that don't actually tell you anything about the identity behind those claims, only the token's basic expiry and issuer, et cetera. Consequently, each new provider needs to be very carefully inspected to make sure that the claims that you select for it are a sufficient identity for publishing. You don't want to accidentally give too many people access to a project, for example. The takeaway from this is that adding new trusted publisher providers, such as GitLab, is somewhat time intensive. You have to actually go and do like a deep dive on each publisher and make sure that you understand what identities are supported by that publisher. And then again, supporting multiple providers means more data model complexity. Again, screenshots. Basically, what we do is we have a bunch of mix-ins that allow us to fan out between different publishers, and that has data model complexity implications for PyPI. Okay, tip 2.5. OIDC varies wildly within IDPs. So again, you might think, oh, well, at least if I only support a single IDP, all of the credentials that come from that IDP will basically look the same. This is also not true, unfortunately. The reality is that OIDC identities vary wildly even within a given provider. For example, GitHub has different claims and different claim formats, depending on whether you are running in a specific kind of CI event, or a specific kind of environment, or a reusable workflow, or a self-hosted runner, et cetera. You can't pave over those differences without finally understanding what you intend to do with those identities that you're extracting. So, takeaway. Supporting every possible configuration that a trusted publisher might have with a given IDP is pretty difficult. Instead, identify the things that your users are actually using and scope down to those. So for PyPI, that was largely non-reusable GitHub workflows for the MVP. We also want to support reusable workflows. Okay, and this is what that looks like. It just creates a bunch of data model complexity. It's really awful. Tip 3, OIDC tokens are not API tokens. Again, you might reasonably think an OIDC credential is just a credential. I already know its scope. I can just directly use that in my authn and authc flows to authenticate a project. And the reality is actually, yes, you can do this if you feel like it. But for various reasons that we discovered during implementation, I would strongly recommend you don't try this. To summarize them, basically, the takeaway is OIDC credentials are not plugged into your pre-existing authn and authc flows. If you're going to extract and verify these things, you're basically going to end up writing and re-implementing a bunch of your pre-existing code to match this new token format. Which means logic bugs. OIDC credentials themselves are also big. They have a lot of state in them that isn't relevant to the identity that you're trying to verify. And critically, the IDP can choose to add more state at any time. So I don't think GitHub would ever do this, but they could arbitrarily decide to add like your full name to an OIDC credential, which now means that PyPI, which you may not trust with your full name, is now handling your PII. So PyPI has to receive that token no matter what, but by storing the credential for longer to verify it later, you're exposing your access to user PII, which you may not want. And then finally, and I think this is the most important one, is IDPs can actually change expiration and other policies arbitrarily. The whole point here is to have consistent self-expiring tokens. But if GitHub someday decides that, oh, all tokens should expire after a month instead, we have now arbitrarily shifted our security model towards whatever GitHub's whims are. And so obviously, we want consistency for the user. So we want to focus things and normalize things down to what we can control. Okay, tip 4, words are hard. We rolled this feature out. The interesting thing about most of this feedback is it came from people who were not actually using PyPI. So the people who found trusted publishing really confusing were the ones who didn't even try to use it. However, I still think this is worth calling out because if we expect other indices to attempt this kind of work, you should know they found the name confusing. We went back and forth on whether we should rename it, but ultimately we couldn't think of a really good name that communicated what it is, which is a trusted identity with another service. We considered calling it OIDC publishing, but that assumes that the user knows what OIDC is, which seems unreasonable. Okay, fine. Final tip. It's all worth it. OIDC is pretty complicated. It's difficult to implement on the client side correctly. The trusted publishing model is many, and is even more complicated on top of OIDC. However, in the last 6 months, the feedback has indicated that the user experience and security gains have overwhelmingly made it worth it. Once they understand it, users have an overwhelmingly positive response to trusted publishing. They basically love that they don't have to configure API tokens anymore. They really want more trust relationships, like reusable GitHub workflows. They really want additional IDPs, like GitLab and CircleCI, BuildKite, et cetera. And they also really want APIs on PyPI itself, as well as UI elements that expose, hey, look, my package is awesome. My package is secure. I have trusted publishing enabled. They're really happy and want more features from it, basically. And then finally, every day that I refresh the stats, basically critical projects are steadily advancing their use of trusted publishing. And like I said, this has a disproportionate impact on the overall ecosystem security. Okay, I'm pretty much running out of time, but basically, to highlight some things that could come out of this, one of the nice things about trusted publishing is it produces an identity relationship between the source repository or the build repository and the publishing entity, such as PyPI. That identity is something that can be reused for code signing. So if you bootstrap your identity trust using trusted publishing, you can then use a scheme like SigStore to verify that identity is in fact the one that should have published for the package. So the side takeaway here is that ecosystems that implement trusted publishing should find it somewhat easy to on-ramp onto schemes like SigStore for full ecosystem code signing. Okay, takeaways. Double win. Usability and security. The best kind of security improvements are the ones that are usable. Others are not actually security improvements. Trusted publishing, everything I've talked about has been tied to PyPI, but the actual concept is not tied to PyPI. Any ecosystem that has a similar type of flow, which is things like NPM and Ruby gems, et cetera, can implement this scheme. And I would love to talk to you in the audience about it. I'll be around. And then finally, this all ties into our shared goals around securing packaging ecosystems. It gives us that first step where we tie the identity of the source to the identity of the build, and that is the critical first step in everything else that we want. Okay, thank you. The slides will be available online, and I don't know if I have time for questions or not.
Yeah, let's make some time for questions here. Actually, is our upcoming speakers here for the next talk? Look. Okay, do you want to get mic'd up, and we'll multitask here? That will give us a few extra minutes. Maybe you have time for 2 questions. Yes.
Thank you.
Thank you very much. So one of the very impressive things that I'm surprised you didn't mention was the earlier policy of providing hardware tokens to Python developers free of charge. Very impressive. So if you'll excuse the leading question, do you intend to expand that to fully self-sovereign identity for authentication, such as passkeys or verifiable credentials?
Yeah, so the question was, do we intend to expand this feature to self-sovereign identities? So I think, you can let me know if this is a sufficient answer. The response is, this feature primarily makes sense in the context of trusting some third party. If you intend to have a fully self-sovereign setup, just use an API token. API tokens will never be deprecated. That is a credential that you fully control and that you can delegate as you please to another service. The risk with adding support for like a random third person's IDP to PyPI is that you are now tying the security of PyPI to someone's maintenance lifecycle. And so we feel comfortable with that for things like GitHub and GitLab because they're big, but for someone smaller, we want to scope their risk down to a single API token.
Okay, last question.
Some of my work that I was doing on pip involved, people also in PyPI making changes, and I was very, very glad about that because, of course, it was part of PEP 605. It was a whole thing. I was interested, I guess, could you give, like, I guess, maybe an overview, I guess? So I'm assuming there were changes, again, that were made into PyPI, as a result of your changes. Were those from Trail of Bits, or were those from PyPI maintainers as well, who I found are actually, well, several of them are very, very helpful, actually. I was wondering, just what is the experience, I guess, with working with PyPI specifically? Because I have a very positive one, and I want to know how this works, like, from a business relationship standpoint.
Yeah, so I think the question was, what is the relationship between PyPI and Trail of Bits, and then what is the experience working with them? So we are a consultancy. Basically, we work with companies that need features or want features in open source ecosystems, but don't have the time or energy or the background to add those things, or they simply want to get it done fast because we have the subject matter expertise involved, and then we have prior relationships with these companies. And ecosystems. For PyPI, we've worked with them for several years. We're not maintainers of PyPI. Nothing I say is an official representation of their policies or anything. Yeah.
Thank you, William. We're out of time, but
right,
thank you.
Thank you.